This section is about finding the solutions to nonlinear inequalities. We're going to look specifically at polynomial rational inequalities and some non-typical ones involving square roots or absolute value symbols. So let's start with a polynomial function that is factored, and we're going to look at all three possible solutions that we could have. We could have zeros. Where is the graph positive and where is the graph negative? I'm going to show this in two ways. First, with the sign chart, which can be used for any problem throughout this section. And secondly, using our leading coefficient test and examining the end behavior. Now that works just for polynomials. So the nice thing is for this function is it's already factored, so we can quickly find the zeros. And the zeros are x equals -2, x equals -1, and x equals 5. Now we're going to use those to find the sections of the graph that are positive or negative, because our zeros are going to divide our graph up into those sections, since the graph will cross over the x-axis at those points. So it'll be changing from negative to positive and positive to negative. So let's start with a sign chart. So a sign chart just takes a number line and looks at points on either side of the zero. So you start out by drawing a number line, arranging your zeros in the correct order. So -2 would be first, then we'd have -1, and then we would have 5. Now what we're going to do is we're going to pick a point on either side of each of those zeros and determine the sign of the polynomial. And it could be any value you want. So I'm going to pick, before -2, I'm going to pick -3 here. And in between -2 and -1, I'm going to pick -1.5. Between -1 and 5, I'm going to pick 0. And then after 5, I'm going to pick 6. Now, I don't have to necessarily know the exact value of the polynomial, just its sign. So I'm going to put each of those numbers in each parenthesis, and just by looking at it, determine the sign. So if I substitute -3, the first parenthesis will end up being a negative number. The second parenthesis will also end up being a negative number. And -3 minus -5 is also negative. So I'll be multiplying three negative factors together, and I get a negative number. So that section of the graph is negative. I'm going to do the same thing with -1.5. So the first parenthesis will be positive. The second parenthesis will be negative. And the third one will also be negative. So as you can see, I'll end up with a positive number. And continuing on, substituting 0, I get a positive in the first parenthesis, a positive in the second parenthesis. Whoops, there should be pluses. And then a negative in the third parenthesis. So I end up with a negative section of the graph. And then for my last one, when I substitute 6 in, I'm going to get 3 positive numbers. So that last section of the graph will be positive. So now I can determine my other two solutions. The sections that will be positive will be the intervals where I found a positive value. So those were between -2 and -1. And also I'm going to put the union symbol, and that's also from 5 and all the rest of the positive numbers, so 5 to infinity. Okay, and then I have two sections of negative numbers. So that would be all the negatives before -2, so we'll do -infinity to -2, and we're going to union that with the section from -1 to 5. So those would be my solutions to number 1. Now let me quickly show how this works with the leading coefficient test. So what I'm going to do is I'm going to start with my number line again. I'm going to put my zeros on. So I have -2, -1, and 5. And of course these are my zeros. So the graph is going to cross over. So I look at my polynomial and I see that it is going to end up with x to the third if I were to multiply that out. and my leading coefficient is going to be positive. So that means the end behavior looks like this. And it's going to end up over here. So in between, it's just going to go through -2. It's going to come back down through -1 and have to turn around and go back through 5. So I can easily visualize where the positive sections are. I can see that I'm positive here and here, and that the two negative sections are here and here. So I would get the same answers using either one.